guys, this is Alan from Plangora, and in this lesson we're going to start to show you just how Elixir is so powerful by showing you one of the best things I think that's actually in the language, which is pattern matching. So pattern matching itself is actually quite unique, and it's not very well known in most other programming languages. But I guarantee once you actually start to use it, you're not going to want to stop using it. In fact, I'm sure you're going to start to wonder, why haven't I ever seen this before? But I must let you know, because it is a little bit complex to understand, I'm going to have to show it to you piece by piece. And the way I'm going to show you first is pattern matching with functions, which helps to make your code much more concise and compact. So let's go ahead, let's get started. So like I just said, when you pattern match with functions, you're going to find that your code tends to be much smaller and much more concise. And also you're going to find out that you're not really going to have to use much conditionals. In fact, I've heard from some other people, and I also tend to agree myself, that if you use conditionals like if and else statements within your Elixir code, then you're probably doing something wrong. These things can normally be done with just pattern matching itself. Another benefit of using pattern matching is to actually get some type guarantees. Because Elixir is a dynamic language, we don't have any static typing to rely upon to make sure our code is actually working properly. But we can actually use our pattern matching to get some kind of guarantee. And within the pattern matching itself, there's some additional functionality called guard clauses, which I'll also go over, which can help you to catch more types of type differences. And also, something that you really need to understand is that Erlang, and therefore Elixir, was built to use pattern matching. And so it's been optimized, and it's extremely fast to do, so don't worry that this kind of thing will make your code run slower. In fact, it'll be just fine. So this is an example of pattern matching that I really wanted to show you. And in this function, we're calculating factorials. So as you'll see, 1 factorial is 1, the factorial of 2 is 2 times 1, and the factorial of 3 is 3 times 2 times 1. But with pattern matching, we can make this much, much more simpler. As you can start to see, there's a little bit of a pattern over here, right? If n is less than 1, we return 1. Else, we're going to return n, which is the number that we passed in, times the factorial, which is the same function we're calling over here, of that n value minus 1. So here's how we can start to make this much, much shorter. If we define the factorial function, and we say that if we pass in a 1, we're going to return a 1. Now, this is also something I'm going to show you right now. This do notation over here is actually just a much, much more smaller way of doing this. This is exactly the same, but because this 1 is just so small, I tend to make this just a single line function as such. And now, since we basically catch this, which I'm going to show you how to catch this less than 1 later on, but now that we catch the 1 of factorial, now we don't need to worry about this one. And because this is also so small, we can do the same thing we did up above. You can see our code is much, much simpler. Now with can try this out using IEX. So this is our pattern matching factorial example. If we do 1, as you can see, when we pass a 1 in, what happens actually is that these functions are checked one by one. We pass a 1 in, we're going to go to 1. And then we're going to go to, since this one matches to 1, we just return 1. Now, if we check 2, it returns 2. Since 2 does not match here, it goes to here, which is 2 times the factorial of 2 minus 1, which is 1. And then it matches here, which is 1. 2 times 1, you see over here, is 2. We can check our last example. 3, 6. Perfect. Again, 3 does not match here. Goes to here. 3 times the factorial of 3 minus 1, which is 2. 2 does not match here, so 2 goes to here. And so on, just like before. Now, we do have one big issue, okay? And that's that we did not catch the factorial of 0, right? Because the main issue is that factorials are only for positive numbers. So the factorial of a negative number won't actually work, because there actually is no a negative number that has a factorial. And remember I mentioned before about guard clauses. We can actually use a guard clause to catch this. So if we do, to do a guard clause, we use the keyword when. So when n is greater than 0. And this will catch that problem. So if we do a -1, well, it doesn't match here. N, well, that kind of matches, right? But this nice little guard clause, -1 is not greater than 0, so it's going to fail. Let's reload our code. So what we can do is let's just do Control-C twice, and then up, and restart our code. So now we can check to see if we actually catch that. -1. Great. And you can see our guard clause passes. Now this is also a great time to show you guys this. Elixir is just amazing to show you what happens, right? So this right here, this number 1, shows you that the first argument, since we only have 1, the first thing that we pass into our function is -1, as you can see. It does not match this one because -1 is obviously not 1. And you can see over here that it matches this part fine, but our guard clause manages to catch it. No function clause matching, pattern matching. This is really powerful. We managed to actually catch errors just by doing this one small thing. Now that's it for today's lesson. This is pattern matching with functions. So I appreciate you guys tuning in and keep checking out the series. Subscribe if you haven't, and feel free to reach out to me if you guys want to know some more, or you have some comments or some suggestions or questions. So again, this is Alan from Plangora, and I'll see you guys next time.